this video, we're going to look at how do we form ionic compounds from the ions. Now, it is really quite simple. Essentially, all we need to do is balance the charge. So, I'm going to show you the shortcut method, and we're going to see how we do. If I had potassium, which has a +1 charge, and I wanted to put it with chlorine that has a -1 charge. So it says we're going to crisscross the number, not the charge, and place it as the subscript. So my negative is going to move down here, my positive is going to move down here, and we know if there's no number written that these just mean 1. So a K plus with a Cl minus just becomes KCl. And realistically, we could figure that one out. If it's a K plus 1 and a Cl minus 1, well, those charges are just going to cancel and you're going to end up with your neutral compound. But what if that's not what we were working with? Let's say we were doing Cl again. But maybe we were working with magnesium. Now, magnesium makes a +2 ion. So, same kind of method. I'm going to cross my negatives down. I'm going to cross my positives down. Okay. And we're not crossing the charge. We're just crossing the number. So, when magnesium and chlorine come together, they're going to give us MgCl2. Now, once again, we do not have to write the 1. It is implied. What if we have more than one number? What if we had aluminum, which makes a +3 ion, and oxygen that makes a -2 ion? So once again, we're going to crisscross our numbers down, and we end up with Al2O3. Now, sometimes you might end up with 2 ions that have equal but opposite charges. So maybe we have calcium, which makes a +2 charge, with sulfur that makes a -2 charge. So in this case, we might first look at this and say, okay, I'm going to crisscross these down, and I end up with Ca2S2. But realistically, that calcium and sulfur, if calcium's a +2 and sulfur's a -2, calcium really wants to give away 2 electrons. Sulfur really wants to take in 2 electrons. So what we're going to do is we're going to reduce these numbers. And this is going to become Ca1S1. Because ultimately, when looking at these oppositely charged ions, okay, these are just going to balance each other out. So all we have to do is write it out as Ca1S1. We're reducing the subscript to the lowest whole number value. So if it's a 2 and a 2, we're going to bring it down. This 2 and that 3, we can't bring it down, so we leave it as is. Now, the next thing we want to look at is how do we name these? Now, this right here is our easy part, okay? Because naming ionic compounds can be really simple. When we aren't dealing with polyatomic ions, now I know I haven't mentioned this word yet, but when monatomic versus polyatomic, monatomic means 1 atom. Polyatomic means multiple atoms. All of these involve monatomic ions. This is 1 atom, 1 atom. So it doesn't matter what their charges are, okay? What we're looking at is the fact that these are all monatomic. It's just a potassium, it's just a chlorine. So how do we name them? Well, all we have to do is we put the metal first. So we take our metal cation, so K plus is potassium. And then we take our anion and we're going to add ide, I-D-E. So chlorine becomes chloride. So this compound is going to be potassium chloride. Now let's do the next one. So we have magnesium. So magnesium, we leave the metal alone. We don't want to change this name. So it's magnesium and then chloride. It's the same as above. Now Al, Al is just aluminum. Now notice I'm not capitalizing any of these because they don't have to be. Now oxygen is one that seems kind of funny because chlorine becomes chloride, bromine becomes bromide. Those seem simple. Oxygen, a lot of times students want to add weird letters because they don't want to drop too much of the ending. But this is just going to be oxide. No oxygenide, no oxygide. It's going to be just oxide. Now, similar things sometimes happen when students try to name compounds that end in sulfur. So we know Ca is calcium. We're going to leave that metal by itself. And sulfur just becomes sulfide. So notice, every time we have a monatomic anion, it ends in these three letters. We're always going to end in ide.